Good morning. Oh, what's wrong with Krause? Something's wrong with him. He's nuts. www.nkinfinity.com. For those of you that watch all of my videos, that's really annoying for me to have to write that every time and for you to go, oh my God, he's writing that again. And then he's going to go over to the website and show us where it is because he never does that either. But here it is. For those of you that don't watch every time, there they are. There's my partner in crime, Miss Nooms. Click on New York State teachers. Even if you're a student, you can click on teachers, and click on review. Click on review. I don't know why I have to do. I don't know. I got to do something different. So here are the practice exams for Algebra 2 review. Algebra 2 review. And then there's my spirals. I'm up through 13. Still got 14 to go, 15 to go. And yeah, we got more review coming. So keep checking out the website. And right now we're just going to rock and roll. This is test number 4. Remember, these are just practice tests. These are just our best attempt. We took a look at old exams and tried to model some questions similar to those, maybe add a couple. So I also have the Regents exams done. For those of you that don't know that, I also have the Regents exams done. So if you go up to the top here and you click on Regents exams, I have them all done. There's Algebra 1. You can click on Algebra 1, Geometry, or here the Algebra 2 Common Core. Unfortunately, there's only 3. There's only 3 exams, so that's why we have to just keep looking for more or practice more. I'm also going to be posting, I don't know what I'm doing right now. I'm also going to be posting a video later about how to get my flashcards. Flashcards. Check out the website. It should be up soon. Make sure you've subscribed. Also, make sure that when you do subscribe, you hit that bell next to the subscribe button. I don't know if I showed you that one before. I'm not even actually exactly sure how to get to that one. Let's try this. Let me log in under this account. That's my school account. And go to YouTube. And, of course, I'm not in there. I'm probably subscribed to myself, maybe. It'd be dumb not to, right? Maybe I'm not. That's weird. I must be. Anyway, search for me. Not Kendrick Lamar, Kendrick Krause. Boom, there. Click on me. And if you click on this, and next to, for some reason it's not showing up here. I don't know why. Maybe this is because I'm still under myself. Why does it do that? Flip back to myself. Maybe that's why. Whatever. Next to this word subscribe, there should be something that looks like a little bell. Click on that, and that'll take you to see when I do live stuff. All right, well, let's get to work. My goodness, enough of that crap. All right, a doctor wants to vector a new drug on patients. She separates her sample of patients into 2. This should say randomly. Randomness is the most important group. Drug into 2 randomly selected groups and administers the drug to only one of these groups. She then compares the results. Which type of study is this? This is a controlled experiment. Anytime you have a control group and one group gets the drug and maybe one group gets a placebo, that is a controlled experiment. What is the value of this? Well, all you got to do is plug in -10 in for x. I mean, you could go to your calculator, do this, -10 control var x, and then just type it in, control division, x over x squared. I think it was -16 would be my guess. Let's see if I can do this. I don't know. It's so weird. Let's try this again. I don't know what it's going to give me this time. Those are not the answers, clearly, right? So, I don't know why they're doing that. I can do exact. All I got to do is go change. I'll change this to exact. I hate exact because this calculator does weird stuff when I get into calculation mode. And I get exact. All right, there it is. -5 over 42. Also, you could have just done -10 over... -10 squared is 100 minus 16. That's -10 over 84. 2 goes into both of them 5 times. 2 goes in here 5 times. 2 goes in here 42 times. -5 over 42. There she is. A stadium has 21 rows I know you were wondering if at 5 o'clock in the morning, oh, it's 6 o'clock, it's so late. If I had my coffee, of course I do. The first row has 18 seats, and each succeeding row, that doesn't sound right, has 2 more seats than the previous row. How many seats are there in the auditorium? Well, you should know that this is a arithmetic sequence formula. Your formula for that is right here. If you forget about it, just go over there to check it out. But it is just a sub n equals a sub 1 plus n minus 1 times d. Don't go here and go, okay, 18 rows, and then 20 rows, and then 22 rows. You're going to be there all day, and you're going to get it wrong. Make sure you know how to do good, appropriate math. Let's figure out what this formula is. The first row is 21, and each successive row has 2 seats. So there's the formula. But now I want to add up. Oh no, the first row has 18 seats. Excuse me. Almost done there, made that mistake. 18. But now I want to add up how many rows there are, how many seats there are in 21 rows. So we're going to use that summation feature of mathematics. N equals 1 to 21 of this formula. 18 plus n minus 1 times 2. So let's use our calculator for that. We're going to go right here next to the 9. It's the big E button. Find it. It's in the second row. Ooh, I even have it highlighted. That's weird. So you do n equals 1. N equals 1. I always go to the top. 21. And then I put the formula in. Formula goes inside the parentheses. Was it 18 plus parentheses n minus 1 times 2. There it is. That's the formula. That's what we get. There we go. 798. All right, this is nothing more. This kind of a question is nothing more than a fancy way of saying, can you find the reference angle? So you have to remember that if I'm doing negative 305 degrees, my initial side is going to be here. Normally, if I'm positive, I'm going to go in that direction. But because it's negative, we're actually going to go in this direction. So negative 90, negative 180, negative 270, negative 305. So there's an angle of negative 305 degrees. Now, what I really want is this angle right here. How big is this angle right here? Well, let's see. All the way around is 360, so this has to be 55 degrees. So we're in the first quadrant. Cosine is positive in the first quadrant, so this would be positive. So cosine of that would be the answer, cosine of 55 degrees. Now, we should check that. So we can come over to our calculator, make sure we're in degree mode. I'm in degree mode. See up here? Check that out. I'm in degree mode. I know I have to be in degree mode because these answers are in degrees. So I'm going to do cosine of, negative 305. Boom. See, what I'm talking about? If you go into exact mode, this thing gets a little funky. I don't know why it would give me that. Just give me the doggone answer. Auto. How about auto? Let's see if auto works. Oh man. How annoying is that? Who the heck would want that answer? Approximate. Make default. Click OK. Ding ding. There we go. All right, and then I'm going to do cosine of 55. And there you go. Same answer. Same answer. All right, let's move on. Question 5. Why is that so far down? That's weird. Weird, bro. Weird. I hope this isn't printed wrong. All right, whatever. All right, what the value of x would be. Now, I'm going to do this the right way, but the actual way I would do it, or probably my kids would do on the test, is stow these numbers into their calculator, type in the left side, type in the right side, and see which one matches. But let's do it the right way. 4 is 2 squared. 2x plus 5. Because remember, what I want to do is get the bases to look the same. Why? I'll show you in a second. I'll remind you in a second. 2 cubed to the 3x. Remember, if I have 2 to the 38.5 and I have 2 to the x, guess what x is? It's 38.5. So as long as the bases are the same, all we got to do is set the exponents equal to each other. Now you got to be careful. What do you do when you have an exponent raised to an exponent? I hope you said multiply, because that is right. 2 times 2x plus 5 has to equal 9x, right? If I just multiply those. Now this one is 4x plus 10. So 4x plus 10 equals 9x. Subtract 4x, I get x. 10 equals 5x, or x equals 2. Now I'm just going to keep reminding you about this stuff. If I took 2 and I stored it into x, and I typed in the left side, which is 4 to the 2x plus 5, 4 raised to the 2x plus 5, press enter, and the right side I get 8 to the 3x, 8 raised to the 3x. I assume you can see that, those are the same. I could have just checked the answers and done it that way anyway, but, you should do it. But my point is, once you have a problem that is completely done, is right, star that thing and don't ever look at it again. Just start. You're done. Problem's over with. Find the value of. Okay, it's all about that base. If you watched the last video, you saw my amazing YouTube video. I know you're impressed. But it's all about that base, and right there is the base. My base is 5. Now, logarithms are equal to exponents. That's just what you need to remember. Logarithms are equal to exponents. So that means this is an exponent. Okay, so that becomes my exponent. And the other thing I like to tell my kids like this is, once I'm going to change its form to an exponential, see how that looks like it's 5 to the x? Well, we're just switching them. So now it's 5 to the 4 is equal to x. 5 to the 4 is 625. Can I check that in my calculator? Absolutely. Control log base 5 of 625 equals 4. Star it. Don't have to look at it again. Oh, this is an interesting question. Okay. Normally I wouldn't do it this way, but we got to kind of do it this way. All right, so there's a couple of different ways to handle this problem. I could just go look for perfect fourths. And 16 is 2 to the 4th. So 2 to the 4th is actually 16. So I'll write this as, 16 is 2 to the 4th. So, and then x squared, you can't do anything with that. And y to the 7th, I can write it as y to the 4th times y cubed. And if I did it the old way, where I'd say, okay, that is 2 and that is y, I end up with 2y 4th roots of x squared y cubed. Well, that's not any of the answers. So that's why I looked at it. I'm like, well, I'm not going to be able to do this the normal way. Now I got to revert back to the other way. And this is a great question. So what we're going to do is this. You need to know what this is. That is the 4th root. Now, if you remember correctly, if I have exponents, like say 3 raised to some exponent a over b, right? This is the root. I always tell my kids roots are in the ground, so roots are in the denominator. Power up. We power up your computer, power up your smartphone, power up yourself with some Dunkin' Donuts coffee. I'm powering up. Any excuse to drink coffee is just an excuse. So the roots are in the ground. So in this case, it would be the bth root. But so what I want to do is I want to convert this, and I want to say, okay, I've got this group of stuff, 16x squared y to the 7th, and really it's raised to the 1/4 power. The 1/4 power. So now I've got a bunch of things raised to an exponent. Okay, so what I end up, everybody gets this exponent, and exponents raised to exponents get multiplied. So this is 16 to the 1/4. X. Now, x 2 times 1/4 is 1/2. Y to the 7th, 7 times 1/4 is 7/4. Y to the 7/4. This, you need to remember or know, is 2. So 2, x to the 1/2, 7 to the 4th, and there she goes. Again, you could stow a number in for x, stow a number in for y, type this in, it will match, and you would star this one. which equation is represented by the graph below. You're looking for exponential decay. All right? That exponential decay means you have a base You have a base that's less than 1. You have a base that's less than 1. And actually I have two of those. These two all have bases less than 1. So it's not this one and it's not this one. The reason it's not this one is because this is really 1/2 to the negative x. And the negative says flip it, so this really becomes 2 to the x. So these two, if I look at them, one of them is 1/2 to the x. The other one is 5 to the negative x, which is really 1/5 to the positive x. Now, how am I going to tell the difference between that one and that one in this graph? And it's all about the point here. That point right there. That point is -1, 2. -1, 2. So if I put in 1/2 to the -1, that's equal to 2. If I put in -1, if I put in 1/5 to the -1, that's 5. Right? I want the one that's 2, so this is the right answer. So this was not just a which one is the decay question, because I could graph those and check it out. But I'm also going to graph it just to make sure. I forgot what the problem was. 0.5 to the x. 0.5 raised to the x. Okay, I said apparently I put 0.5x. How about raised to the x? There it is, and it goes to this point right here, 1, 2. Right? If you wanted to look at the other one, just to take a look at the other one, press tab and do 5 raised to the negative x, you'll see the difference. All right, tab, 5 raised to the negative x. And you'll see that this one goes through, right, this one goes, that's probably not good to look at it like that. Whatever. So this one goes through 1, -2. This one goes through -1 and then 5 or something like that. So that's why. I don't know why I got all those tabs open. All right. Wow. Okay, so this one, I remember this one. This was on an old Regents exam. First of all, if you don't know this again, the geometric sequence formula is right here. You always use it. Oh, go back this way. No, this one. So the geometric formula sequence is a sub n equals a sub 1 r to the n minus 1. All right, so now you got to figure out well, you don't have to figure out what a sub 1 is. A sub 1 is negative square root of 5. R is the ratio from this one to this one. Now, in order to find the ratio, you got to do a sub 2 over a sub 1, or a sub 3 over a sub 2, or so on and so forth. So what we'll do is we'll do the square root of 10 divided by negative square root of 5. Well, how many times is 5 going to 10? Twice. So this is really negative square root of 2. Now, let's see if that makes sense. If you multiply by negative radical 2, do you get this? Yep. And if you take this and you multiply it by negative radical 2, do you get this? You actually do. What you end up getting is negative square root of 20. But 20 is 4 times 5. And the square root of 4 is 2. That's why it's that. So this is negative radical 2 to the n minus 1. Now comes the craziness. They want the 15th term. So let me write this a little bit neater, just so you can see it. So a sub n equals the square root of 5, or was it negative square root of 5? I don't remember. Negative square root of 5, negative radical 2 to the n minus 1. So they want the 15th term. So we're going to put a 15 in here. So my new exponent actually is going to be 14. So negative square root of 5 times negative radical 2 times 4 to the 14th power. Now, you can either use your calculator for this one or your brain. Because that's even, because this is even, I'm only going to look at this piece right here. That means there's going to be 14 groups there's going to be 14 of these things, or 7 groups of these. So really what I'm going to have is negative square root of 2 times negative square root of 2. That's one group. Negative square root of 2 times negative square root of 2. And I'm going to have 7 of these. Why am I doing that? Because each one of these is positive 2. This is positive 2, this is positive 2, this is positive 2, this is positive 2, and so on. So really what this is 2 to the 7th power. Negative radical 5. Well, I'm going to guess 2 to the 7th power is 128. And 128 times negative 5, or negative square root of 5, is negative 128 square roots of 5. Now, I could, if I wanted to, at this point, just type this in, and then just type this in. I still have to come up with this formula. But once I do that, I could just type that in, plug in 15 for n, and see if I get it, and I do. Which one is skewed left? Well, if you draw these things, this one's relatively symmetrical, maybe a little bit skewed. This one's just kind of odd. That one's a little bit skewed too, but that would be, and then this one is severely skewed. And then this one is severely skewed. So, skewness follows the tail. So you have to find the tail. Here's the tail. There's the tail. There's the tail. In this case, there's the tail too. This one would be considered slightly skewed right. This is heavily skewed right. This one is skewed left. Which one are we looking for? Which one is skewed left? Choice 4. Period. Period is equal to 2 pi over b. Remember, this is A, this is B, and here's C, which we don't have a C. C is the shift up or down, right? Your midline. All right, so 2 pi over 3. Done. Problem's over with. Last problem. What is the range of this? Well, this is a parabola. This is a parabola in vertex form, which means my vertex is negative 4 comma 7. So negative 4, 7. There it is. It's also pointed upward. So if you were to graph this on your calculator, if you were to come over here to your calculator and graph it, go into graph mode, and just type in x plus 4 parentheses squared plus 7, you would get something you can't see, but if you drag it down, you'd get that parabola. There it is. There's your parabola that you'd get. Well, range is y values from the bottom to the top, from the bottom to the top. Isn't that a song? But in bottom to top, I don't know. So it's going to start here at 7, and it's going to go forever and ever up. That means y is greater than or equal to 7. That's it, kids. That's the first 12. Those weren't bad. Those were bad. A couple of weird ones, but they weren't too bad. All right, keep checking. Hit the subscribe button, hit the like button, and check out NK Infinity for the rest of these exams in a nice, organized fashion for yourself. All right, bye.